Right. So welcome everybody again. Thank you for joining. Do you guys see my screen all right? Awesome. Perfect. Let me just do some organizational work here. Great. So today we're talking about the process functional modeling within PRIZ innovation platform. Something that was released fairly recently. And that's another level of analyzing processes. Now, as usual, we starting with a quote, in this case from Edward Deming. If you can't describe what you're doing as your process, you don't know what you're doing. And Edward Deming, he introduced the theory of quality management, and he was American engineer and manager a bunch of books in the field. One of the interesting things he also said that we need to improve the product and improve the quality of product, quality of the process as well. And inherently by doing that, we're reducing the cost of the process as a whole. There's a lot of other other things that he said as well, but we're going to concentrate about the processes today and how do we identify what do we do with them and how do we find the ways to improve that and where to improve that. So first of all, what is functional modeling? What are we even going to get from it? So process functional modeling is, again, it's an analytical tool like most of our tools in the platform. And it helps us to learn the process in pretty high details. And understand how the process operates. Then we able to dive deeper into each and every one of the operations and understand how these pieces operate. We can analyze and understand the functional value of every operation. And we will see some examples of how we do that and some real examples as part of the case study at the end. Now, we're doing all of that to be able to make strategic and tactical decisions. Now, what that really means, strategic decisions is basically the what within the long and potentially complex process. What do we need to improve? How do we do that? So the tool is helping helping with that task, and the tactical decision is the how. So, for example, we chose a particular operation to improve. Then the question is, how do we do the improvements? And the tool will help him with that too. Another not less important thing to understand is basically we create a common language within the organization. And as you probably know, the management and the engineering many times talking completely different languages. And the process functional modeling kind of allows us to create that common language and look at the system and at the process in the same way. It doesn't matter who looks at this. Now, what's important to understand is the process functional modeling is applicable for any type of process. Doesn't matter engineering, non-engineering, whether it's even process within family life, right? Or complex manufacturing processes. Now, we can use it for designing or improving existing processes, designing new processes, reduce complexity, by that reducing the cost of the process overall. Of course, we just talked about the quality of the process and eventually the quality of the product that it creates, or in other words, yield. We're doing it by identifying the redundant operations or low value operations, so we can potentially even remove them altogether. And of course, many companies, they hold lean and Kaizen events or many other types of similar events, and it can be used there as well. But the list can go on for a long time. Now, the first thing that we want to ask is, what is the process in general? So the way that we define it, the process is some human-made system that is there to create a product. And we'll talk about the product in a second, but basically product is something that carries a value, right? Now, any process can be described with three things. It's the energy that it consumes, the process itself, and the product. So the energy, it could be the actual energy, electricity, it could be raw materials in different types of forms, it could be information, documentation, whatever the process needs to create the product. Now, the process itself, of course, it is that system that takes the energy and converts it into the product. And the product, as I already mentioned a second ago, it is that thing that carries a value. It could be food, like the examples here, the clothes, devices, electronics, anything else that you consider as a value, and it doesn't matter really what it is. And by the way, please stop me if you have any questions at any moment. Now, how do we start? Where do we start? So first of all, it's important to understand that process is a series of operations, regardless of what process is. As a first step, we need to build that series of operations. We need to identify each and every one of them, understand which order they go in, and in general, that's a pretty easy task. Again, the energy goes from enters from one side of the process into the first operation, and then the product comes out of the last operation, of course. Now, what's next? The next is basically we need to answer. We want to answer several questions. Is given this process, the potentially long series of events and operations, how do we improve it? Which one of the operations we improve? Which one we could potentially eliminate completely, and so on and so forth. Like, how do we improve the quality of this process? And this is where the process functional modeling becomes really useful. Now, as the next step, once we build the chain of operations, we need to define the type of operation. So that's a very, very important step, and we'll see in a second why. In general, there's four types that we defined in at least in PRIZ. There's four types of operations. One is productive. It is something that creates an irreversible change within the product. As an example here, boiling an egg, drilling a hole, something that in general irreversible. You changing the final product. And in another word, you're basically adding a value to that. So you're taking something, you're changing it, you're adding a value. Next operation, if it's productive, you're changing it again, you add a little bit more value, and so on. Providing operation, and an example, a really good example is soaping the hands before we wash them, right? It's a providing operation. We're not changing the product at all. It's not an irreversible change. It doesn't add a value at all, but it is sometimes necessary, like in order to wash the hands, right? Or fixate the metal plate in order to drill, and so on. There is, again, endless examples. Corrective operation, as you can imagine, for example, you're doing a renovation. Again, outside of the examples that are written here, you're doing a renovation, there's a lot of dirt, now you need to clean it up. That's one of the corrective operations. It's mainly irreversible. Once you cleaned it up, it is clean. It's nothing to do about that. It may or may not add value to the product itself, right? Because you might, for example, clean the product, but you might clean the I don't know, the building where it's getting created. The value to the product may or may not be added. And then metrology. Metrology is something that is sometimes necessary, but it's basically when we inspect or measure something or test something, we're testing the product. It doesn't add the value to the product, but it adds value to the management, for example, and we will see in a second why. Now, the interesting thing that we're observing across the world, that the productive operation typically not going over 25%. And if you think about it, it's pretty ridiculous. Now, in average microchip manufacturing, it's actually not going over 16%, right? So we adding a value to a product, to a final product, only 16% of the operation. Everything else is, if you think about it, it's fix something that's broken or rework something that needs to be reworked. It's an inefficiency within the project, within the process. And then, of course, metrology is used in all of these different places, and we'll see an example for where. Now, let's dive a little bit deeper into these types of different operations, and we'll start talking about the strategic decisions that we can do with their help. First of all, again, productive operation, as we talked about this, it's an irreversible change in an object. It increases the value of operation. So strategically, we do need to invest our efforts to improve these operations and invest into these operations to make them better, faster, more efficient, and so on. Providing operation, again, it's a temporary change in an object, increases the value, may increase the value of the final product. It will increase the cost of the value of the final product because it's an additional operation, but it never increases the value, right? So again, strategically, in ideal case, we should either simplify or remove them completely. Right? Corrective operation.
Just a moment, yeah. Alex, could you very interesting example from microelectronic microchip manufacturing. You know, photolithography is the most expensive operation, and this is providing operation. And as to me, it's out of sense. People invest a lot into photolithography. They should think how to eliminate photolithography. Last switching to EUV lithography, it's huge, and you know, you invest money and you never add value to the wafer, to the chip. This is, as to me, it's a typical example of wrong strategical decision. Thank you. Sorry.
No, it's all good. Now, to continue with the same thought of photoresist and the photolithography, corrective operation, something that is even in place because of bad performance of the productive operation and the fact of the existence of providing operation. So if we take in the photolithography as an example, there's a photoresist that we're putting on a wafer in this particular case. Now we're doing the work that we need to do. Now we need to remove it, right? That would be a corrective operation. So we're basically doing something in order to throw it away. Doesn't really make much sense if you think about it. Again, strategically, don't invest in there. Remove it, eliminate it, simplify it as much as you can.
Not develop. No, never develop.
Yeah, don't improve it. Don't improve it. In general, it's like ideally you should improve the productive operations, and by doing that, you're eliminating completely corrective and providing. Now, metrology is, again, there is no change in the product. There is no value added. The whole target of metrology is to create information. Usually information for management or managing the process as a whole. And the question that we need to ask is do we even need that, right? And in many cases, it's not necessary. In many cases, especially when we're trying to remove the corrective operation, let's say, for example, you did some measurement, now you need to rework a product. But if your original providing operation is perfect, let's assume it's perfect. You don't need neither measurement or providing or corrective operation, right? So again, invest in the productive operations to potentially remove even the metrology. But in majority of cases, we say metrology is needed. We need to understand how the process operates. We need to understand what the quality of product we potentially catch if there is something going wrong. Then we do need that information to make these decisions and to find the inefficiencies if they come along. But again, we need to be very, very critical about this and understand if we don't need this information, just throw it away. We don't need it. It just adds cost into the product.
I see Juan is asking a question. Juan, please ask your question.
Yeah, apologies. My video is off because it's misbehaving. The question is, very often you have a decision step. So would you normally characterize that decision step as a metrology step or as a providing step?
Can you repeat that again, sir?
Yeah, you have a decision to make that you can call that a process step, right?
Sure.
So would that process step be considered metrology typically,
yes.
or would you call it a providing step?
Absolutely, it is a metrology for sure.
Okay, thank you.
Yeah. Any other questions on these things? This is a pretty important step. It's pretty important to understand what it gives us and how to operate with that. And again, this is the first step of this is strategic decisions. Basically, the what. It's answering the question is the what type of operation, which operation we're gonna strategically decide to improve or work on or invest in.
Now, just one comment. This is really very important. Very important to understand that we should define which type of operations do we have and be focused only on productive operation. By the way, even if we trying to produce metal from concentrate from ore, we dissolve it. After that we precipitate it. It's a lot of not productive operations. We should try to eliminate it and think about single productive operation.
Right. I want to go to this example, not example, but this chart again, to this pie chart, and remind everyone the only thing that adds value is this productive operation, and it's typically very, very low percentage of the whole process. So everything else is money wasted, time wasted, lost opportunities. So if you think about it, everything else but productive operations, that's the opportunities to innovate.
Right.
Right.
Emilio, please tell your comment.
Yeah, it's a short question. Can we apply these principles to business processes?
Absolutely. Again, I'll go to this slide here, that it is engineering, non-engineering processes 100%. The process is the process. It doesn't matter what you do in the process. The process of analyzing it is the same, right? And we'll see that in our example today, that it could be from as simple as washing machine to some very complex engineering processes in microchip manufacturing, right? Or in general, it could be even some processes within the family that are taking place. Sorry, I'll just mute that. Cool. So let's continue from there. Now, once we have that mapping done, we're starting to dive deeper as we mentioned, and diving deeper is basically understanding the how do we improve the one or another particular operation. And to do that, we need to understand how that particular operation even works, how it functions, what's the deficiencies in that. In simple words, we need to understand the efficiency of that operation and identify which is the least efficient and invest in that. In many cases, invest in that if it's productive. So what we do in this particular case, we take each and every one of the operations and we build a functional model for it. Some people who were in one of the previous webinars where we talked about functional modeling, the process of building a functional.
Alex, just a moment, please. Could you return? I see Varsha is asking question, please.
Mm-hmm.
Yeah, Alex, so I wanted to know one non-technical example.
For example, management, right? In managing a group of people, there is also always a process as well. Managing a group of people, managing a group of engineers, it's not necessarily engineering problem per se, but it is part of the process. It has a process built into it in order to manage people as well, right? So that managerial process can also be analyzed.
Maybe if I can come in, and Alex,
of course,
as well.
Of course.
So I'm working on an example myself. I work in the Department of Justice in Ireland, and the process that I'm trying to improve is the international protection for asylum seekers. So that's an example, very close to what your HR processes could be. So it is about people coming in, having an interview, a report being produced, and then a recommendation being made, and then the decision taken. So that's a typical process that you can map following this process.
Excellent. Excellent.
Another good example, it could be a client onboarding. New client comes in, you need to sign a contract with him, you need to train him, so on and so forth. It is a process at the end of the day. HR, new employees coming into the company, they're going through some sort of a process. And companies typically trying to make it as efficient as possible, so people onboarding as fast as possible to waste less resources on that.
Yeah, Alex, that's correct. And thank you for the example, Leon. Actually, I was trying to see how I can fit in these processes, HR processes, into productive metrology and providing buckets. So, each process is not going to give you some kind of a productive output, obviously, because those are operational processes. So I was just thinking, how can I bucket these HR processes into these areas like productive metrology providing and,
Right. So even in metrology, so it sounds like a lot of the operations within that HR process is metrology, right? I think, I don't know, even reading somebody's resume from a very, very, very beginning, it is a metrology if you think about it. Right, you're trying to understand, is that person even worth going forward with? Right, it is type of metrology. Now, we'll talk about this in a second. The most important thing in every operation when you analyzing every operation is to identify what is the product of that. Right. In metrology, it could be a little bit tricky to understand it, but there is always a product. It could be information, it could be measurement, which is kind of information. But I don't know. To me, it sounds like metrology is always providing information, and that is a product. Now, different types of information, yes, but at the end of the day, it's information that, based on that information, you're making decisions going forward within the process.
Oh, thank you. For the clarification.
Thank you.
Any other questions on this? All right, I'll move forward. So back to functional modeling. This is where we analyzing every operation in a deeper details. And as I mentioned a second ago, we need to identify the product as a first step. It's very, very important. What is that product that this step creates, or what's the target of that particular operation? Once we did that, we can fairly easily understand and map the components of that operation, whether it's people, different pieces of software, it doesn't matter what it is, but it's something that we typically can affect and we typically have control over. Identify the super system components. It's something that we cannot typically control, but it is affecting the end product. It could be error around us. It could be other dependencies from third-party companies if it's management.
High salary in neighbor company. It's regarding HR. Yeah,
sure. Yeah, it could be that, or pandemics.
Right.
Then we're identifying the functions, and functions is really function by definition is something that changes the value or changes the parameter of something, right? In this case, we're talking about component. It will change the parameter of that particular component. And what we're doing here, we mapping the functions between the components, and we'll see the examples of that. The end result of this whole mapping, we calculate two things: functionality or functional ranking, or harmfulness or problematic ranks. Thank you. And it calculates it per component and as an operation as a whole. Okay. Now, this also helps us to make a decision where we need to improve in the overall system, in the overall process, excuse me. Any other comments here, Anatoly?
No, it's okay.
So typical example, or something that might look like a typical example, is the chain of operations. And this is a screenshot from PRIZ platform. Is we have different types of operation. They are color-coded for different productive, providing, corrective, and metrology. And once we map the functional model within each and every one of the operations, and we'll see how to do that, we're getting these little numbers in here. And the blue is the functional rank for the operation, not for a particular component, but for the entire operation, as well as the problematic rank, and this is the one in red. Now, this number below is very, very important when we that helps us to make our decisions, and that's the ratio between functional and problematic rank. And realistically speaking, the lower it is, the less efficient. We created a threshold saying if it's under 2, it's inefficient. Okay, and we need to basically invest in those or completely remove those. And in this particular case, we have the providing operation, productive operation, which looks pretty good by the numbers, and so on and so forth. And that's kind of the last step of the analysis. After that, we can actually start making decisions where and how to improve. And I'll pause here for a moment if you guys have any questions.
Of course, the best way to eliminate operations with low efficiency, I would say, don't fix if it's broken.
Alex,
Richard,
I have a question. Can you identify contradictions in this type of functional analysis?
I had a question though, if I may.
Yes, Richard, let me answer the Amos's question first. It cannot identify, it will help you to identify contradictions when you're analyzing, right? Because what happens along the way when you're working on the model itself, when you're building, especially the functional model, right? What typically happens, ideas come into your mind. But what does it mean, idea? Hey, we can do that, but something else will break. Or we can improve here, but the cost is going to be high, and so on. So it's the thinking process that will help you to identify contradictions versus just give you the contradiction as an outcome of a tool.
But okay, but when you calculate harmful operations, you have to identify also useful operations in parallel?
Yes. Well, useful, there's no such a thing as harmful or useful operations. If it's harmful operation, the operation shouldn't even exist. To be honest, I mean, if there is an operation that breaks a product, for example, that would be harmful. On the level of operation, we usually talking about efficiency. So whether it's efficient or not, right? Is it costly or not? And that's all, again, all about efficiency. The function could be harmful. So when we're talking about the functional model level, the function could be harmful. For example, air heats, overheats a person, right? It's a harmful function. It's not something that's desirable. It's just there. There's nothing we can do about it. And there's multiple examples of harmful functions. So harmfulness is in the functional level. On operational level, we're talking about efficiency.
I see.
Okay. Richard, you had a question? Richard?
Your next slide.
Oh.
The question that I asked was the red and blue lines. How did you determine the numbers that you put in there? Like the first slide has basically a 1-to-1 ratio, and then it's benefit is 6 point something and the negative is 2 point something. How did you determine those numbers?
It's a formula that we're applying. So very.
Are we going to get to that?
We're gonna be, well, we're not gonna talk about the details of the formula itself, but it's basically determined as a collective harmfulness of or usefulness of the functions.
Okay.
Richard, it's more or less similar as Tech Optimizer did it for functional modeling, but we modified it a little bit. And in the calculation of problematical harmfulness, we took into account how far this component from the product. You know, if it's very far, it's less impactive, and it's very closed. It's more impactive.
Okay. We'll see.
Okay. Yeah.
I'm just curious about the method because, you know, I've seen other representations and.
And by the way, even for functional analysis, we've seen, at least, if I'm not mistaken, 4 different formulas and 4 different approaches. There's nothing wrong in all of them. Right. I don't think there is a one right or wrong question. Right? It's more of it's a matter of approach. It's a matter of, excuse me.
It's more or less a guideline, you know, reference.
It's more or less a guideline, right? It's a matter of, you know, how much you want to highlight a particular problem or where the problem is, and the same as what Anatoly mentioned, we decided to take the distance into account as well from the product and so on. But again, there's a number of different approaches into that. We just one of them.
Okay.
Any other questions before we jump into the tool itself?
I'm good. Thank you.
All right. Great. So as a next step, what we wanted to show is actually how to use the tool inside the platform. So somebody who's new, anybody who's new to the platform, our platform is built in form of projects. Any problem that we're working on is a project. And in this case, we already created one. Since the process of analyzing processes can be potentially pretty long, it is a piece of work. But at the end of the day, the result is pretty impressive. Now, before I dive into the real example, and we literally talking about laundry, right? And the reason that we took this example and not something from microelectronics that we typically do is to make it, to enable understanding from everybody, not necessarily only from industry, and because it's also a little bit of fun. Now, first though, I want to show how do we mechanically use the process and where the buttons are and everything. And the process functional modeling is one of these, one of the tools that we have available in the system. We can start using it again as any other tool. We have the description of the process that we have a place for, and that's really anything. We'll see an example for that. It's the free form of us as engineers or as analyzers to describe the actual process that we're trying to improve, and the modeling step itself as well. So every step that we adding, we chose a generic name of a step, but in general, it's that type of it's that operation within the process. And as we mentioned in the presentation, it's a linear approach. So any process can be described in a linear way. Once we created these number of steps, doesn't matter how many of them, we need to.
Oh, just a moment. You can change the title of.
Yeah, I'll get in a second
okay.
there in a second. Yeah, let's go in the title. So changing in title, operation 1, whatever, do something, and so on. So these, we're updating these titles to make it talk to us in a single language. Again, that's one of the pieces that allows us to talk to our management, us as engineers, to the management in a particular way, in particular language that they understand and we understand, and the other way around. The next step, as we described, is defining these types of operations. So as we've seen, there's productive, providing, corrective, metrology, and so on. So it could be corrective, it will be color-coded, productive would be color-coded. I'll add a fourth, so we have all 4. Providing, of course, and metrology. All right. Next, we dive into the functional model. And functional model, realistically, it is just that same functional model. Currently, it's given the same name. Again, the functional model, we're talking about one particular operation where we're analyzing one particular operation with its own product. And we start modeling that. I think it's useful when I'll set the recording out of that. I'll send the recording for functional modeling webinar as well, because they very much go hand in hand. But in general, this is where we're defining the functional model. And let's say, I don't know, let's say this is going to be a harmful operation, and the rank's going to be calculated in here. Again, this is not a real example. And when we're going back to the flow, these things are calculated immediately, and they're available. Okay, and of course, at the end of the day, once we have all of that information gathered and available, now we can build the conclusions and come up with some ideas of solving the original problem. So let's dive into the fun example of the actual laundry. So we're talking about laundry, as we all know and familiar with. And of course, the process operations, we just described them very briefly in here. We're loading the clothes, we need to wash them, we spinning them, rinse them, and so on and so forth until we iron it, so they're ready to be worn again. Now, the model that we ended up building looks like that. As you can see, there's only 2 productive operations in here. But we're starting with inspecting the clothes, even understand, does it need to be washed, right? Then we're loading them into the machine, we're washing them inside the machine, then the spin, drying them either within a machine or maybe in another dryer, unloading them. Oh, sorry, I made a mistake. It goes in a zigzag. We rinse the clothes, spin, unloading, drying them, and then we need to iron them, right? So if we go into one of the operations, and as you can see, as I mentioned, these operation, what we call it, operation merit, it's how efficient that particular process is, right? And in this case, this is a pretty high, where an example is a lower ones, it's the ones in red, everything under 2. And this is the corrective operation where we actually spinning and basically removing the water that we just added. It's inefficient, right? If we dive into the functional model of that particular operation, if we dive into functional model of that particular operation, we can see in details, and again, we pre-mapped it initially because it takes a little bit of time to build. What type of components and what type of product in this particular case, the product is water, because this is what we're trying to remove and get rid of. The product is water. There is nature, which is the super component. We can contaminating that. There is different components like pump, dissolved dirt, and so on and so forth. There's many pieces into that.
Alex, I think we need to change our function to nature to harmful, and you can show how to do it. Yeah.
Correct.
Yeah.
Right.
Excellent.
So as a result of this modeling, we getting calculated ranks, right? And the ranks, there is again what we mentioned, the functional rank and problematic rank for every component within this particular operation, right? So all the components that we mapped in here, they're gonna be presented either harmful or useful, quote unquote, or both. Like in this case, the washing machine drum, right? Now, if we're going back to the flow, by the way, that number will potentially change, right? But it's still 1.27. This is where we seeing, first of all, again, useful or productive operations within the washing process is just very few, right? Now I want to dive into this ironing and drying. Again, what we've seen here is steam. We have the person who irons. We have the water inside the iron, right? We have the air and so on. So if you think about it, we have all the possible components or all the possible ingredients to do the washing in the first place, to get rid of the dirt in the first place, right? It's just a question of how do we do that using an iron, for example. It might sound a ridiculous example, but the conclusion that we came into is we need to put all the entire functionality of the washing into the ironing operation per se.
I think it's in proposed solution page.
Right, we'll get to the proposed solution.
Okay, I'm sorry.
I wanted to pause here and hear from people on the call what they think about that, or maybe some other ideas that come into your minds. And again, looking at the model itself, we have a bunch of corrective operations. So it's kind of ridiculous. We want to remove dirt, but then we adding water, we adding chemicals, and we doing all of that to remove dirt, but then we need to fix everything that we did. So we need to remove the chemicals, remove the water, dry the clothes, and it's a lot of stuff that we need to do after the fact, after the clothes already potentially clean.
Yeah, I think, Alex, I think there is a fundamental choice in your model here. Either you consider the ironing a corrective operation, or you could consider a productive one. If you consider a corrective one, then you could try then to avoid wrinkling the clothes in the first place, and so that you don't have drying, right?
Correct. And by the way, we had this conversation internally as well before we dive into the webinar. And you can see it definitely as a corrective operation, because you wrinkle the clothes first when you wash them, and then you need to correct it, right? But if you think about it, before, when you're wearing your clothes, they already wrinkled, right? So even if you skip the washing and go directly to ironing, sometimes it happens, we adding a value to the product, to that shirt, for example, right? So if you're looking at this from this perspective, it's actually productive operation, right? So it could go both ways. So it is a little bit of gray area, and it's again, you need to think about whether or not it adds a value to the product, right? Can it be done without the previous operations? May or may not be. So that's one thing. And then another thing I wanted to say, but I lost the line of thought. Sorry about that.
But Alex, you do not take into account that most of the clothes today do not need any ironing.
That's one of the solutions. Another thing that for example, there's I don't remember what they call it, but there's little sheets that you're adding into the dryer that helping you to reduce the wrinkles.
Yeah.
Right. There is that. Whether it's effective or not, yes, it helps. So, I know many people who don't iron because of that, because it's good enough for them. So that's another option. But yes, there was a trend of trying to remove even the need of ironing or reduce the number of wrinkles on the clothes that coming out of washer and dryer.
Very good. So what would be your next step here? What would you select to improve first?
So what we proposed, got into proposed solution is what I mentioned is potentially, we don't have a solution of how, but potentially put everything, all the functionality of cleaning the clothes, whatever that means, into the iron itself. Again, it has water. We can potentially add chemicals into that. It has the heat. It has the only thing we need to learn is how to remove the dirt using the iron, right? The analogy, it could be wet carpet cleaning, where you have it's basically ginormous wet vacuum that removes dirt. You can think about it as a laundering a carpet, right? So we didn't dive into the how to achieve that, but that's our idea of proposal. Again, there is no right or wrong answer. It's an opportunity for where it can be developed, where this process can be taken into, where to innovate eventually.
But to choose that, you were based on on the ranking. Could you show us the ranking again?
To choose that, I was based on ranking as well as my own line of thought.
Okay.
Right.
Let's say you should improve which adds value. Don't think about operation which doesn't improve, doesn't create value.
Right.
This is the direction.
Yeah.
Richard wanted to tell something or ask something.
Yeah, Alex, as the problem is set up, I got a little confused between model for cleaning the clothes or for saving water.
It depends what you're defining as a problem, right? There's many problems in washing, like you're saying, wasting water, contaminating environment, and so on, potentially maybe wasting time. Again, it's back to the problem statement, the problem definition, right? For somebody, wasting time, it's not a problem in washing because he actually enjoys it. No problem with that. He can do it all day long. For somebody else, it's not. He needs to do it fast. Some people very, very cautious about the environment. They want to do everything possible to save water, not to contaminate with chemicals and so on.
Alex, I see we have another question. Yes, please.
Herman, what did you mean? How do you define dirt?
Yes. Yeah, in fact, what is dirt? We have very loosely defined dirt. Are you able to hear me?
Yeah.
Dirt would, the clothes become dirty not only because of the external dust. They also become dirty because of sweat. Second is what is called as sebum, which is the oily substance which the skin secretes. All this, they create odor. Sebum creates odor, sweat creates odor, and then they also have some solids in that which get stuck, and it is also oily. So, how do you, if you say that a iron press has to be used as a cleaning substance, so how do you tackle these three things together? And I also do not know, but it must be happening that detergent is tackling all these three. Is it doing it well? We need to have a process analysis of detergent itself as to how it acts on.
It could be. It could very well be, for sure. Yeah. Again, this is one of the ideas that we had. Depends on what type of problems you have, and you're absolutely correct about even understanding how detergent works, right? Maybe it makes sense to break this process down into even smaller pieces and saying, okay, we're loading the detergent and we're adding water, then detergent does something, and that becomes a much lower level process that we need to analyze. 100%.
Do we need a detergent in the first place, or do we need a detergent which is a significant modification of the existing? And do we really need water, or does steam do the work of water? Because some of the processes like making paper, it was very inefficient process by using water. But then they changed it by using steam. It has become very efficient process and saves a lot of water. So,
excellent.
And that's a perfect example.
I really love your idea that that the iron press itself should wash and press the clothes. I really love that idea.
Maybe again, we need. Sorry,
Antonio. One thing that I'm always coming back to over and over again. It's extremely important. What is the problem that we're defining? What is the problem that we're trying to solve? Because all of these modelings, especially the functional model, we're not modeling the system just for the sake of modeling the system. We're modeling we're trying to understand how we can create that problem that we're observing, right? And understand how the system, the current system, creates this problem, right? Then we can think about, okay, we understand now the model of the problem, how the problem even created. Then we can think about how to solve it and who is mainly responsible for it. There's could be multiple components that are responsible for it, but now we're identifying which ones are responsible and focus our thinking into that direction.
You know, Alex, Helmut raised a good question, because not always the clothes are dirt. Sometimes we only need to refresh them, you know, after wearing them for all day long. So they are not dirt, but they smell not good, probably, and we just want to refresh them. So,
you know, somewhere a long time in France, as you know, where the perfume came from, they decided instead of bathing, they invented perfume. They solved the problem of an odor, right? They didn't care about whether they clean or not. They cared about the odor. They solved it with perfume. Okay, right? That works too.
In fact,
Amelia,
you know,
had a
can I make a comment, please?
Of course, of course.
Yeah, in fact, you know, all these cleaning problems, I was thinking of one of the cleaning problem is that in India, the dishwashers have failed badly. Even though washing machines have succeeded, dishwashers failed badly because of peculiarities of Indian cooking. So while thinking about how to solve that problem, one of the root causes that comes out is that two suspended or dissolved materials with liquid, when the liquid evaporates, they bond very strongly with the solid, which is the utensils. Or same problem will happen in the clothes also. When there is a sweat and when it evaporates, these solids involved in it would bond very strongly with clothes. How is that we are going to break these bonds? Why these strong bonds are created and how we are going to break these bonds?
Okay. Again, is that the question to us or?
Yes. You know, in fact, this is the, you know, for all cleaning problem, this is the root problem we have to solve.
Okay.
You can use ultrasonic.
Yeah, exactly. Fields.
Yeah, ultrasonic or bubble cavitation. Bubble cavitation is another thing I was thinking of.
Ultrasonic and add some different gases that will vary the surface tension of the bubbles. So the efficiency will dependent on the properties of the liquid.
Yes.
Right.
Yeah.
So as you can see, guys, and Emilia, I'll get to your question in just one moment. As you can see, guys, as most of the tools, what they forcing us to do is to think in a very specific direction. Now, solutions, different types of solutions could be endless, right? What we are doing though is getting to the point of where do I want to address the problem? What is the operation that we want to invest into, right? And then maybe even analyze that particular operation even deeper and understand and dive into and find the contradictions if we have some ideas and solve the contradictions with 40 principles and understand even why the operation does what it does with root cause analysis. This is where all of these tools all of a sudden glued together and starting to produce the bigger value. Now, Emilia, the example from software engineering, we don't necessarily have the examples right now. We didn't build one. But again, software engineering has many different processes. I'm coming from software. There's anything from the process from, you know, trying to define what the customer wants all the way to implementation and deployment, right? So any process, again, it consists of series of operations. Every operation can be broken down and analyzed. So it doesn't really matter if it's coming from software, from rocket science, or it doesn't matter where it's coming from. It's still a process, and we're analyzing it in a very similar way. Does that answer your question? And if you want, we can spend some time and actually build that.
Yeah, I meant for the functional analysis part.
Mm-hmm. Functional analysis is still, again, the same thing. For example, I don't have it in this account. I have it in a separate account on PRIZ, but we did analyze the build process and how do we improve the build process. Improve mean we were concerned about the speed of the build process, and what we were able to identify what is contributing to that extra time that we don't really need or we want to get rid of, and which components were responsible on it, right? I can dig up a couple of examples for you and send it over if you want. Juan, can you?
Yeah.
So do you count any interaction? Yeah, go ahead.
Yeah, so sometimes you may have elements in, let's say, step 1 that have an interaction with step 6, right? For example, imagine you want to eliminate something in step 1, but it's something that you're going to need later in step 6.
Okay.
So do you have any connections between elements from different processes, or so that when I try to eliminate something, at least I get a warning saying, "Oop, this is there, don't, you will need to transfer some other functionality if you same this."
I would need a more detailed example. I know what you mean.
Yeah.
But I feel like since an operation within any process has a target to create a product, whatever the product is, right? And that would be the end of that operation. Now, adding something to be useful in a completely different operation, is that something that becomes part of it, like inseparable part of the final product? And then it's not really used as in part of the operation, just part of the product, right? Or is it something that needs to be removed after? Then my question would be, why do we add it in the first step and not?
Yeah, but sometimes
just a step before.
Sometimes you have the output of one step will be the input of another one.
Yes, that's the energy. If you remember, that's the energy or part of the energy of the next step.
Yeah. So, okay, I'll try to find an example, and if I identify it, I'll send it to you. Yeah.
No problem. Happy to dive into that for sure.
I just remember from using Tech Optimizer that there were connections. There was a way to connect to use some connection between elements of different steps, and I think it was useful when trimming. I just need to dig it up and try to remember. Yeah.
Right. Again, happy to dive into that. Happy to dive into any examples, and definitely if we missing some use cases, we'll analyze and find a solution for that.
Yeah. No, thank you.
So one thing that we're still kind of missing in that final step as any other project, the process functional modeling tool is also presented in the final report. So we have all the other information as well about the project, what was the project background, if there is problem statement, we just didn't define it in here, proposed solution, and so on. And then the process functional modeling with all the details that we gone through from the high level, and then is broken down into the functional models of each and every one of the steps, each and every one of the operations, and what was the outcome of each and every one of them. And that is in the report, exportable, or some of them haven't been actually defined. Exportable report. Another piece of information that is many times useful for managers more than engineers, that they like reports.
You don't need PowerPoint. You can present your project using the report.
Right.
Yeah, it's very good. Yeah, it really nice.
Guys, what I should say, use this platform. It's working. It's working very, very well. And it has two functions. The first function, it helps you to understand how your process, how your system is working. Because if we think we know how our tool, how our group of the people, how our HR is working, it's wrong. We should analyze it, and we should understand it. And since we understand it, we can improve it. We can make it low cost, reduce cost, and improve yield. And we are open for your questions. Call us anytime you need our participation, and please propose our platform in your companies. And if you need our participation for workshops, we're ready to do it, and it will be very useful and fun, I promise you.
Yeah, it is a fun project. It almost becomes like a game working with these tools.
Alex, can I ask you one question in here?
Of course.
Can we take it as a thumb rule that we should eliminate or try to eliminate a harmful function by a corrective function, by providing introducing an providing function before the corrective function, so that the defect itself is not created?
Right. So one of the rules, if you remember from here, sorry, that's metrology. The corrective and providing function. So corrective function is, it's needed because of bad productive functions, or because we even have the providing functions, right? So for example, we adding soap to water and then we're trying to remove the soap. We, I don't know, we're creating a wood dust and then we now need to clean it up. And multiple examples, right? We're doing a car maintenance. There's a lot of dirt in the garage. Now we need to clean that up, and so on. So yes, by improving or investing into productive operations, we potentially reducing the need of corrective and providing 100%.
Exactly. Think about productive operations. Leave aside all the rest. Just wasting money and time.
Any other questions? We a little bit over time, and apologies for that.
But it was cool.
It was a good presentation.
Yeah, thank you very much. I really like the tool.
Thank
and
you.
One of the good things that I see in it as well is that it makes it easy to educate other people. I know how to do functional analysis, but it's very difficult to educate people using PowerPoint. This is much easier to get them from 0 to 100 in a more reasonable time. So,
right. What we've seen across the board in many cases, where people start using these tools, functional analysis, process functional modeling. Again, it's almost like a game. You're playing with it. You're playing with Lego blocks, right? You're kind of understanding where things fit. Do I, as an engineer, even understand how this thing works together, right? And so on.
Yeah, thank you.
Thank you, guys.
All right. I will stop the recording.
Thank you.